It's St. Patrick's Day, but I need to talk about IMF. So let's talk about fluoroscein, the dye that was originally used to dye the Chicago River green. First thing you need to look at with IMF, or intermolecular forces, is the chemical structure of the compound. Fluoroscein has the chemical formula C20H12O5, and here's what it looks like. I am using organic nomenclature, but more on that in just a second. So what we want to think about is which IMF is this compound going to experience, and I'm going to focus on these four: ion dipole, dipole-dipole, hydrogen bonding, and London dispersion forces. So first of all, it will not experience ion dipole interactions. This is because these interactions exist when an ionic substance is dissolved in a polar solvent or solution. So when we add salt to water, it's going to separate out into its ion. Dipole-dipole interactions are interactions between polar molecules. We need to look at this molecule now and decide whether or not it is polar. So looking at it right away, my carbon to oxygen bonds and my oxygen to hydrogen bonds are polar. The carbon to hydrogen bonds are non-polar, but because I have some polar bonds in here, it's not symmetrical. This is going to be a polar molecule, so it will experience dipole-dipole interactions. Next question is, will it experience hydrogen bonding? So hydrogen bonding is a specific dipole-dipole interaction between hydrogen in a polar bond and a very electronegative atom, such as oxygen, nitrogen, or fluorine. The sites in red indicate where this will happen. The last one to think about is London dispersion forces. Guess what? Everything experiences that, so go ahead and check that every time. Follow Chem with Corinne for more content like this.